All right, this is Unit 2, Analyzing Data, and this is the second video on significant figures. Significant figures are important for showing accuracy and confidence in a measurement, as we found in the last video. And we're going to look at them again today. The importance of significant figures a lot of times is so that we can, one, show our accuracy in a measurement and our confidence, but two, so that we know how and where to round when we're doing calculations. A lot of students, especially students in advanced math classes, like to write down every single digit that the calculator tells them. And that's, in general, too many significant figures. It's too accurate for what we're doing. And in reality, the calculator also rounded the answer. A lot of calculator answers will go on for many digits past where the calculator shows you. Here are 5 rules for determining significant figures. Rule number 1, non-zero numbers are always significant. So any digit that is 1 through 9 is significant. They are going to be important. So really, the only numbers that are in question are zeros. Zeros are the only things that we really have to worry about. Is a zero significant, or is it not significant? When is it significant, and when is it not? Rule number 2, zeros at the end of a number are significant when a decimal point is present. These zeros are showing accuracy. For instance, 1.0, 3.000, 10 with a decimal. Each of these zeros is significant because there is a decimal point present. They are at the end of the number, and there is a decimal, and these are showing accuracy. Think of it like this example. If I told you that I have $1 in my pocket, I might actually have $1.02. This could round to $1. Would you be that mad at me if you asked me if I had $1 and I said yes, but I actually had $1.02? Not very many people are counting 2 pennies. Not going to be a big deal. However, if you check your bank account balance, if it says you have $1.00, this is an exact amount. Because look, here's the decimal, and these are showing accuracy. We know for a fact that this is $1. It's an exact amount, and we know that it's not going to be $1.04. It's not going to be $1.02 like I had in my pocket, and it's not going to be 98 cents. 1.00, this means you have $1. So zeros at the end of a number when a decimal point is present. They are significant. Rule number 3, any zeros between non-zero numbers. So remember, all non-zeros are significant, so any zeros that separate them are also going to be significant. Some examples: 101, 40.005, or 40,005. Either way, all of these zeros are significant. So far, we have non-zeros are significant, zeros at the end of a number with a decimal are significant, and zeros that are between non-zeros are significant. Here's where we see zeros that are not significant. Zeros that are called placeholder zeros are not significant. These zeros indicate the magnitude of the number, meaning how big or small is this number. And they give us an idea of where the decimal point would be. The easiest way to tell if a zero is a placeholder is to put the number into scientific notation, and the placeholder numbers will disappear, the placeholder zeros. 0.0005. These are all placeholder zeros. These are not showing accuracy. These are just showing me where the decimal is. If I put that one in scientific notation, it would be 5 times 10 to the negative 1, 2, 3, 4. And they disappear. Here we have 100. 100 without a decimal. These are not significant. These zeros are just showing me the size of the number. If it was 100 with a decimal, it would fit into rule number 2, and it would be all significant, both of those zeros. But it's not. This is just a 1 with 2 zeros and no decimal place. So these zeros are not significant. The same thing with this example of 1 million. There's no decimal point, and these are showing the magnitude of the number. They are not showing any accuracy. These zeros just show me that this is a big number. 0.0000065. These zeros are not significant. All they are doing is showing me how small this number is. They're showing me where the decimal point is. If I put this into scientific notation, 1, 2, 3, 4, 5, 6, 6.5 times 10 to the negative 6, then I see that they just disappear because they weren't significant. A note on scientific notation. If we come back up to rule number 2, and let's say we have a number that is 3,650 with a decimal. Remember, this zero is significant because it's at the end of a number and the decimal point is present. If you put this one into scientific notation, it would be 3.650 times 10 to the third. Because this zero is showing accuracy, it has to show up here as well. The fifth rule, counted numbers or defined constants. They don't affect the significant figures. They're not going to affect what we're doing. For instance, 12 feet. There are 12 inches in 1 foot. If we were using this to figure out, say, how many inches in a mile, this would not affect our measurement because it's a conversion, it's not a measurement. Same thing with things that we counted. So we have a certain number of students in this class. I'm actually teaching an empty room right now, but let's say we had 17 students in this class right now, and I physically counted 17 students. Well, we don't need to limit our calculations on accuracy based on 17 because I didn't measure this, I counted this. Let's leave that blank. You can fill in your own number another time. Let's look at some examples. Determine the number of significant figures in each number. So we'll step through the rules here and talk about how many significant figures. First example, maybe I can get all the rules in here too. Yeah, good. First one, 163. All of these apply to rule number 1. These are all non-zero digits. Significant, 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 So it has 3 significant figures. This number, 4.00, the non-zero is significant. And then we have some zeros. Are they significant or are they not? This one is rule number 2. They're at the end of a number and there's a decimal point. So both of these are significant. There are 3 significant figures. 0.4240. So let's start off with the non-zeros. Those 3 are significant. And let's see, rule number 2, at the end of a number, when a decimal point is present, that's this one. It is significant. This 0 applies to rule number 4, placeholder zeros. This one is not doing anything except showing me where the decimal point goes. It is showing me the size of the number. So this one has 4 significant figures. The number 200, the 2 is significant, the non-zero. There are 2 zeros at the end of a number and there is no decimal point, so these are not significant. These are placeholders. There's 1 significant figure here. 3.450, non-zero, non-zero, non-zero. A 0 at the end of a number with a decimal, that applies to rule number 2. That one's significant. 4. We'll come back to this one. 401. We have 2 non-zeros. That's rule number 1. And we have a 0 in the middle. That's rule number 3. It is significant. 3 significant figures. 50.22, non-zero, 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 0 in the middle. This one has 4. 4,005, non-zero, non-zero, zeros in the middle. Rule 1 and rule 3. This one has 4. 0.0012. These 2 are significant, and these zeros do not show accuracy. These are placeholders. They show me where the decimal point goes. They show me how big this number is. They are not significant. Here we have one in scientific notation. 5.090 times 10 to the 4th power. So we have a non-zero, another non-zero. We have a 0 between them. And we have a 0 at the end of a number with a decimal. This one's showing accuracy. And we have this 10 to the negative 4th. 10 to the negative 4th does not affect significant figures. Those don't count. So this one has 4 significant figures. All right, now to these bottom middle ones. 404,280. I've got non-zeros. I have a 0 between them. That's rule number 3. And I have a 0 at the end, and there is no decimal point. So this one is going to be a placeholder, rule number 4. 5 significant figures. This next one is always a favorite for the test. Not this exact number, but if you had maybe a handful of these, there's always going to be one like this where it hits almost every rule that is up here. So let's look at this. 0.0235020. Starting off, rule number 1, we have non-zeros. Rule number 2, there is a decimal and there's a 0 at the end. That one's significant. Rule number 3, zeros between non-zero numbers. That's this one. That's significant. Rule number 4, placeholder zeros. That's the 0.0 right here. These are not significant. The function of these is just to show us the location of the decimal point, and they do not show accuracy. They just show us the size of the number. So this one has 1, 2, 3, 4, 5, 6 significant figures.